A girl slides down a slide that has inclination of 26 degrees with an acceleration of 2 meters per second square. A bit. What is the coefficient of kinetic friction between the girl and the slide? Next. Once the girl reaches the ground, her mom gives her a quick push up the slide and then lets her go. If her velocity when her mom lets her go is 5 meters per second, how much distance does it take for her to come to a stop? Next, if the girl has a mass of 23 kilograms, how much force does her mom need to exert in a direction parallel to the slide's surface to push her up at the slide at constant velocity? Let us do the problem. This is the slide, and let us assume that this be the girl. Okay, the mass of the girl is equal to 23 kilograms. And then the angle is 26 degrees. So this angle is also 26 degrees. Okay, now this is FG, and then this is FG perpendicular, and this is FG parallel. And we have 3 different bits. Now we do each one separately. First, bit A. What is the coefficient of kinetic friction between the girl and the slide? That we have to find out. For that, what we do, what are the forces acting on her? Fg parallel is acting downwards, and then F friction acting in this direction because the girl is sliding down. Okay, so we write, I take this direction as positive, this direction as negative. So what I do is F sigma Fx is equal to Fg parallel minus F friction is equal to MAX. Okay, now here A is given to us. This is the direction, and then A is equal to 2 meters per second square. Okay, now what I do is here I will write the what is Fg parallel and then friction. For F friction, I will write the y component motion, y component equation, force equation. Sigma Fy is equal to, this is Fn. Okay, Fn minus Fg perpendicular is equal to MAy. But Ay is equal to 0 since there is no motion along the y direction. Therefore, Fn is equal to Fg perpendicular. Fg perpendicular is equal to, this is adjacent side to the angle. Therefore, this is the cos. Okay. Therefore, Fn is equal to mg cos theta. Okay. So, F friction is equal to mu k mu Fn. So here this is this one mg cos theta. Therefore, this is equal to mu k mg cos theta. Okay. Now here Fg parallel. Fg parallel means this is perpendicular to the this one, or opposite side to the angle. Opposite side to the angle means a sine component. Okay. Therefore, mg sine theta minus mu k mg cos theta is equal to MAX. Okay, mass goes off, and I'm left with this one. Now I will substitute the values. G is equal to 9.8 sine 26 degrees, sine 26 degrees minus mu k. I have to find out mu k times 9.8 cos 26 degrees is equal to a value given to us, 2 meters per second square. So that is equal to 2 meters per second square. Therefore, mu k is equal to, or I will write this one, the value. This value is 4.296, 4.296 minus this value is minus mu k, 9.8 into cos 26 is equal to 8.808 mu k is equal to 2 meters per second square. Therefore, mu k is equal to 4.296 minus 2 divided by 8.808 is equal to 0.260. This is the value of mu k. This is the A bit. Okay, next what we have to find out. Once the girl reaches the ground, her mom gives her a quick push up the slide and then lets her go. If her velocity when her mom lets her go is 5 meters per second, how much distance does it take for her to come to a stop? Now, for this, what we do is we have to find out the distance. So acceleration we have to find out. Then we will find out the distance. So here, what is happening? FG parallel is in this direction, and then FG now. What is happening? The girl comes down, and then the mother pushes her up. Okay, when the mother pushes her up, the applied force is in the upward direction, and then the girl is going up. So that is why FG parallel is downward direction, and F friction is also downward direction. Okay, so sigma Fx is equal to, this is B bit, sigma Fx is equal to F applied minus Fg parallel minus F friction is equal to MAX. Okay, she's going up. Now, what we do is we use this equation to find this one. So once the girl reaches, her mom gives her a quick push up. Now we have to find out the distance. So first we find out the acceleration. So for that, what we do is negative, Fg parallel is negative mg sine theta, negative mu k mg cos theta is equal to MAX. Okay. Now the girl, once the lady gives the push, the girl is moving with a constant velocity. Okay. So the F applied vanishes once she will not move with constant velocity. Only thing is the applied force vanishes because the mother gave a push and then leaves her. She is not continuously giving the force. So that is why F applied is equal to 0. That is the reason I haven't put the F applied is equal to F applied. Here I am taking only these two. You may be wondering what happened to the F applied, because she just gives the push and then leaves. So these two are the forces responsible for the acceleration. Now mass goes off, and then the rest of the things are here. So here what happens, this is negative 4.296, and then this is negative friction. When we multiply this one will become 2.296 is equal to acceleration. Okay, so acceleration is equal to negative 6.592 meters per second square. Okay, now I have to find out the distance. So to find the distance, what I do is I will take the equation Vf square is equal to Vi square plus 2AD, kinematic equation I will take, and then I will find out. Finally, the girl is coming to a rest, therefore 0 square is equal to initial velocity is, she is moving with a velocity of 5 meters per second. So plus 2 into negative 6.592 times distance. Therefore, the distance is equal to negative 25 divided by negative 13.184. That is equal to 1.896 meters, or that is equal to 1.9 meters. This is the distance she goes. Now, C bit. If the girl has a mass of 23 kg, how much force does her mom need to exert to push her up at the slide at constant velocity? So for that, what we do is we will find out the mass into acceleration, no? So same equation. So F applied, we have to find out F applied. So F applied minus Fg parallel minus F friction is equal to 0 because the constant velocity, she is moving with constant velocity, so this must be equal to 0. Therefore, F applied is equal to Fg parallel plus F friction. Okay, and what else is there here? Into we will find out this one. So this is equal to Fg parallel is equal to mg sine theta. No? So mg sine theta plus mu k mg cos theta. Okay, so here what I do is I will take the mass as her mass is given as 23 kilograms, 23 times 9.8 into sine 26 degrees plus F friction is, what is the F friction? I will find out. Mu k is 0.260 now. So 0.260 times 9.8 into cos 26 degrees. Okay, so this gives the F applied is equal to 200 and what is the value? 151.432 newtons. Okay, this is the answer for this one. Okay. Here what this is the answer for this question. Now you may be you must have understood this one now. The first part is very easy for you. Okay, because the sigma fx is equal to fg parallel minus f friction is equal to max, and we are writing the equation, this equation from the force diagram, and then we are finding the mu k. And then when it comes to the b bit, the fx is equal to f applied because the mother is pushing the child up and then leaving. So the push is only at the kickstart to the child to go up. It is not always there. So when the girl starts moving, the F applied becomes 0 and then Fg parallel minus F friction is equal to max. That is why I haven't put anything here. So for your understanding, I will put this as 0 minus this one. So that means F applied is equal to 0. Okay. So then with this equation, we can find out the acceleration. And then once we find the acceleration using the kinematic equation, we can find out the distance moved by the child. And then finally, the questioner is asking us to find out the force, how much force the mother applied for the child to move this much of distance. So for that here, the child is moving with a constant velocity. Therefore, the force equation sigma fx is equal to F applied minus F friction is equal to 0 because there is no acceleration. Constant velocity means acceleration is equal to 0. The C bit constant velocity implies A is equal to 0. So F applied minus Fg parallel minus F friction is equal to 0, or F applied is equal to Fg parallel plus F friction. So I substituted the values here. With that, I got the answer. Okay. This is how I did the problem. Hope this helps. Thank you. Bye-bye.